Hello, good afternoon, and thank you for sacrificing this lovely sunny afternoon, the first one we've had this year, to come and listen to me for 10 minutes, or 15 minutes, talking about insulation boards. And my name is Mark Bowman, I'm the Technical Manager at Marmox UK, and today we're going to focus on probably not one of our most well-known products, but it's a product which is sort of fits in with the more sustainability sort of theme of today's event, which is our Fireboard, which also in some countries is called the rock board, which looks an awful lot like that. This board is essentially, as you can see, a type of mineral wool, stone wool, clad on either side with concrete. We'll talk about this as we go on. I'll try and keep the microphone in the right position as well so you can hear me. So yes, so what we're going to talk about. First of all, a very brief introduction to who our company is, Marmox. We're an international company. We're actually based in Cairo. That's our main headquarters, although we did start in Germany, long story there. But we exist all over the world, and we are involved in some major projects, such as we do the Shangri-La bedrooms in the Shard there some time ago, and other substantial buildings. But that's enough about us, because we've only got 10 minutes. Let's talk about what else we do. The main thing that we are probably more well known for is our thermal bridging solutions. Nothing at all I'm going to be talking about now, but that's my area of expertise, thermal bridging products. We produce a product called the Thermoblock, which is used to improve your energy assessments, if you have such a thing in your requirements. But anyway, let's talk about what we're going to mention today. Today we're going to do a brief sort of summary of what thermal insulation is and what acoustic insulation is, because they're the main two properties which this particular board of ours addresses. How we'll do it, we'll talk about the two major applications. External wall boards, what they do, the benefits of them, the problems that could come with them, and the solutions. And then we'll do the same approach to talking about ceiling insulation boards, which could also include to some extent internal wall insulation. Again, we'll talk about what it is, what the benefits of those products are, the problems it causes, and the solutions to it. Here's a picture which you've probably seen lurking around on the internet. It's a pretty much nonsensical picture because it's all made up really, but it gives a vague indication of where most of the heat leaks out of your property. It is regulated, of course, with building regulations. The thermal insulation is governed by Part L in England and Wales, and also in Southern Ireland. And this gives us worst case U values. U values, as you may know, is the rate of heat loss from the inside of the building envelope to the outside of the building envelope. You can't have it too bad, otherwise you're going to be losing too much heat. It's determined by your theoretical amount of CO2 which is generated to produce that heat, your carbon emissions rate. We also have something, a primary energy rate, which looks at the theoretical amount of energy which a house is going to use over the course of a year. And there's another measurement in there which the energy assessors will look at called the fabric energy efficiency, which looks at the continuity of insulation. So if you've got lots of gaps, you're not going to score too well on that. There are targets, of course. At the moment, the U value target in England and Wales is 0.18. In roofs, because as we saw, we lose a little bit more heat through the roofs, it's a little bit tighter, 0.11. A few years ago, it wasn't anything like as tight as this. Just 10 years ago, it wasn't 0.18, it was 0.35. So if your house was built to regulations more than 10 years ago, you can see that you're losing more than double the amount of heat. That was seen as permissible back then. Even older, 25 years ago, which doesn't seem that long ago to me, but 25 years ago, that U value requirement was much slacker. So if your house is at least 25 years old, even if it was built to the regulations then, you can see that compared with modern builds, it's much more flexible. Acoustic insulation, let's talk a little bit about that, shall we, as well. Acoustic insulation. Well, to understand what that is and how it's regulated, first of all, a very brief sort of summary of what noise is. Noise is essentially how our brains determine changes in air pressure. Sound is carried on waves, of course. Waves have different frequencies, and the frequencies which us humans pick up is between 20 to 20,000 hertz. Obviously, dolphins and dogs can hear different sounds to us. That's why your dog hears a noise that we can think, what are they barking at? There's nothing there, but they have different frequencies. And it's all to do with the shape of the wavelength. If it's a tight frequency like that, a tight wave like that, the frequency is higher because it's 1, 2, 3, 4, 5 in that short area. A lower frequency, it's much more fluid. Just to say that again, high frequency, high pitch short waves, they're the high pitch sounds. If it's low frequency, they're the much more bassy, drony noises. And the different frequencies travel through buildings at different rates. How does it travel through sound? This does come up later, don't worry, it's not just going back to doing O-level physics. If your material where your sound wave is going through is tightly packed like that, a solid, tightly packed molecules, that sound waves gets into that molecule and it finds one next to it, bounces into that, bounces into that, bounces into that, and you can see as it goes through that solid, it gets bigger and bigger and bigger. That's why if you have a tiled floor in a bathroom, for example, the sound you hear below is louder than the sound at where it starts with. It accentuates the noise. If you have a liquid, then those particles are more spread out, so that sound waves have to wait for a particle to approach it before it can pass its vibrational energy onto it. Da-da-da-da-da-da. And if it's a gas, even more difficult, because then you have to wait for a particle to appear next to it before it can pass its energy on, or it just gives up, like in that case. Right, acoustic insulation. There's 3 different types of sound insulation that we need to address. There is reflected sound, that's the blue waves, where the sound bounces off a surface, gets distorted and just sounds a horrible mushy noise. If you go into certain restaurants and pubs where they've got nice shiny white painted ceilings, then that noise is horrible and it just an awful noise. If you've got a surface which is more rough, then that sound is not going to get vibrated back to you and not going to get distorted. The green arrows. Now let's talk about the red arrow first, shall we? I've not done this one before. You can tell, can't you? Impact sound, that's the noise you get directly from transmitting through the floor. So if I'm banging on the floor like that, if I was underneath, I would hear that because it's literally passing through the material. That's sometimes quite an easy one to stop, but the one which is most difficult to stop is airborne sound. That's the sound which passes through the air, through materials, and that's usually quite a tricky one to address, and you do need quite specialist sound insulation materials for that. Sound insulation, the passage of sound through buildings is regulated with our building regulations, of course. We have section E of the building regs. But it's interesting to note that those regulations only govern the amount of sound passing within the building. If your house is at the side of a railway line or a side of a motorway, part of the building regulations do not regulate the amount of sound which comes from the outside to the inside. It's only noise from inside which is accounted for here. If it is impact sound, that's that one. There is a maximum amount which is allowed to pass through from one room to another. Certainly if you've got hotels, blocks of flats, etc., then the housing association, the local authorities will regulate the amount of impact sound which can pass through from one floor to another. If it's airborne sound, that one I said is more tricky to address, then there's a minimum amount of insulation. So it's not the amount of sound which is passes through, it's got the minimum amount of insulation. And there are also reductions in place to stop that bouncing off the walls, the reverberation sound. Let's talk briefly about that one, reflected sound. It's measured in a concept called the absorption coefficient. Imagine if we had a lion trapped in a box for some reason, and that lion is roaring. The red line is the amount of sound which it's emitting. Some of that sound passes through the wall. Some of that sound bounces back off the ceiling and back into the line. Some of it is absorbed into the roof. If you take away that from that, you've got that left, the blue. That's essentially how we determine the reflected sound. If it's a number of 1, it's good. If it's 0, it's very, very bad. So when we talk about acoustic insulation for sound absorption, we want that index to be as high as possible, as close to 1. There's a lovely picture here of someone having taken an improvised approach to this, putting a carpet on the wall. That will certainly stop the sound bouncing off the walls. That will be a nice quiet room. But another material which we can use is mineral wool or stone wool, or I'm sure they're in this building somewhere, is rock wool, a very famous manufacturer of stone wool, mineral wool. Mineral wool is known to be one of the best sound absorption materials in the world. Its alpha index is above 0.75, so it's a class A material in that respect. Airborne sound, that's the one which goes through the walls. How is that addressed? Well, there's 3 ways of stopping it. Sound blocking, what does that mean? Well, we mentioned earlier that if you've got your particles really tightly packed to each other, then that wave of energy can pass from one particle into the other one, passing its vibration along through it. But if that material is so densely packed it can't vibrate, then you have a sound blocking material. Sound decoupling, that's another way of doing it. That's by putting in gaps, air gaps, so that essentially it looks a little bit like the liquid diagram I showed, where your particles are fairly spread out, so that wave needs to sort of find a route to get through that material before it can pass its energy on. And the other way is a sound absorbing material that converts the sound into heat energy. Mineral wool, there it is again. Is it a sound blocker? Well, obviously not, because it's not dense at all, so it's not doing it that way. Is it a sound decoupler? Yes, it is, because essentially this stuff is full of air. It's mainly air, that stuff is. And so all those minerals are widely spread apart, so it's not that easy for the sound waves to travel through it if there's no easy conduit to go through. So yes, it is a very good sound decoupling material. Is it a sound absorption material? Well, I've mentioned before, yes it is. Mineral wool, stone wool or rock wool, whichever one you want to call it, extraordinarily good material for absorbing sound. And if you ever wanted to know what it looked like if under a microscope, here's the answer there. External wall insulation. For renovation, this is seen as a very, very simple, well, it's not that simple, but it's a straightforward approach to improving the thermal insulation of a building, and it also is renderable on, if that is a word. And it can also provide acoustic insulation. Remember, Part E of the building regs only govern the amount of sound transmitted within a particular building, not the sound from outside of a building. So if you wished to improve the amount of, or the reduction, try again, if you wanted to reduce the amount of sound coming from the outside to the inside, you would put a sound insulation material on the outside like we have here. It's used very commonly for renovation purposes, and probably not so much in new builds, because if you get a new build, it already will come with that sort of, the guaranteed U values and alpha values. But it can be used to improve existing buildings, because we saw those U values from years ago were nothing like as good as they are now. So if you want to get your building up to modern standards in terms of thermal insulation and acoustic insulation, you can stick some of this on the outside of your building and Bob's your uncle, so to speak. There are problems, of course. There's problems with everything. If you've got EWI, it can be impermeable. If it's non-breathable, it means that all that vapor which you generate inside your house, because nearly all of this sort of The vapour which goes through walls is from the inside to the outside. It's a common misconception that when you waterproof your buildings, it's to stop the moisture from the outside coming in. It's really the other way around. But if it's too impermeable, all that moisture is going to get trapped and you will get a sweaty house, so to speak, with awful condensation problems. Sometimes the EWR material is too thick, can't use it in certain areas. Sometimes it's combustible and sometimes it's non-rigid. So let's talk about the first one. Impermeable can cause condensation. What's the solution to that? A breathable board, a breathable insulation material such as, here it is again, mineral wool. I nearly said rock wool, but mineral wool. But rock wool also does the same thing. It's virtually the same product. So our Fireboard would be ideal for that. There's another product called wood wool, which is incredibly not very popular in this country, which is popular elsewhere. Excellent product, but it's not something that you see too often, and it's not something we promote either, so why am I going on about it? I don't know. If you have a non-breathable board, such as a polystyrene board or a Kingspan or a Celotex, then if you use that, you must ensure that you have improved your ventilation. It's no good thinking, oh, I've got all these air blocks here, that's letting the cold in, I must block them up. Bad thing to do. Must not do that. Breathability is extraordinarily important. The other problem, sometimes it's too thick. The beauty of our product, sound like a little bit of a salesman here, but the beauty of our product is we can make it thinner. This, what we've got in the core of that, is no different to those big slabs of rock wool, those big slabs of mineral wool which you can get, but they are generally 50 mil, 100 mil, 150 millimeters thick. And sometimes it's just not convenient to put these great big chunks on the outside of your house. If you've got intricate designs, if you've got corners, reveals, you will not be able to use that very easily. So with ours, it enables you to have a smaller, thinner section of mineral wool. Admittedly, if it's thinner, it's not going to be as effective in insulation, of course, but it does solve that problem of being able to put a thinner board on the outside of your buildings. The thinnest ones we do are actually 12 millimeters, which is that thick. They're also not very light, they're not very heavy either, so they can be easily manipulated. They're all sold in fairly small sizes, 600 by 1200, so they're easy to manage. And there's one place where you certainly wouldn't be able to fit big slabs of mineral wool around the dormer windows and reveals, etc., etc. Combustibility, of course, that is very important, and to be honest, that is why we introduced this version of the board to the UK anyway, about 18 months ago, because our primary boards up to there were our polystyrene boards, which we've been selling for about 30 years. But the mineral wool is non-combustible. It's A1 rated, so that means completely fireproof, as would be, of course, stone wool and rock wool. Certain places you cannot use a combustible material if it's a Class E, if it's above 18 metres, which will probably be coming down to 15 metres very shortly, or if your building is less than 1 metre away from an adjoining property, it has to be an A1 rated material if it's used externally. Therefore, you will need something like this. And as I said, ours is A1 rated, and it's also being tested with a render coating on it, which would be the normal coating for that if you're using it externally, but not exclusively. But if it's got a render coating, we've got 1 hour's fire resistance from it, which will mean it will protect whatever is on the other side of it for at least an hour, even if there is a raging fire. In this case, it was 1,000 degrees, and on the other side of that, we put some Kingspan or something like that, which would burst into flame if it wasn't protected. Non-rigid, so requires a supporting layer such as plywood on a frame. Again, what our board is rock wool, not rock wool, I must stop saying that even though I'm being recorded, and rock wool will sue me in a moment, mineral wool or stone wool, but it's coated on either side with a layer of cement, or it's polymer modified cement. epoxy cement, and that means it's rigid, it's hard, even if it's a 12mm board. A 12mm layer of stone wool is a hard, rigid board, and that means it can go directly onto frames. You don't need to support it behind. As these pictures show, this was a small extension which somebody not too far away from us were doing, and that's been put directly onto the timber studs at 600 centres. There is the result. Not only used in small buildings, I say in the UK we've only been selling this for 18 months. In Germany it's been much more popular, and there's some much larger constructions over in I think they were in Munich. But it can also be used in internal wall insulation. But to be perfectly honest, I can't really see many benefits on using this type of board internally, because the polystyrene version would do the job a little bit better. And also internal wall insulation takes up a bit more space. If you're putting it externally, then you've got a lot more scope. Ceiling insulation, why would we do that? Generally to improve the thermal and acoustic insulation. You can use this product instead of plasterboard, but why would you do that? Because this is a thermal insulation board, so it's going to improve that heat loss which goes up through the ceiling, which, as we saw earlier on that made-up diagram at the very, very beginning, that's where a lot of it goes through, and it can bring it down by 10 to 15% in theory. It does depend, of course, on your construction. It's never always going to be the same. And acoustics, yes, it's going to have a good effect on reducing the sound transmission from one room into another. There's someone putting it up. And problems we get with it. Sometimes ceiling insulation board can be quite thick, so it'll lower the ceiling more than you want. Sometimes it needs to go on a suspended ceiling system. Again, that's going to lower it. This doesn't need to be done that way. Some of them are not acoustic. If it's just plasterboard, it's not acoustic. Some are combustible. And some cannot be plastered on directly. Thick, and it lowers the ceiling. As I've already said, our boards are 12mm and 20mm, so they are commonly used for this application. This has become, just in 18 months, this has become quite a big seller, so we're very, very pleased about this. And it's generally used as an alternative to plasterboard because it does the same job as plasterboard, but you get these extra benefits from it. Some are not acoustic, so what's it doing? It's improving the airborne sound insulation, and it's also improving the insulation at those specific frequencies where we can hear it. Another problem, again, it's sort of repeating myself with what I was saying, the external wall insulation, is some are combustible. This is not one of our products, I will point out, but this is a frightening example of what is being sold nowadays in the UK. That picture was an insulation board which this guy got a lighter to, lit that burst into flame. That picture was taken probably no more than 3 seconds after he lit it. It's quite scary that these are still available after Grenfell, but they are. But the solutions are to use a stone wool based or rock wool based material because they are A1 rated. They cannot burn. It is totally impossible. And some cannot be plastered directly on. No problem at all with all the other solutions being replaced with, say, a slab of mineral wool. But you wouldn't want to just put that on your ceiling and plaster it. That's not going to be achievable. But because ours have got that rigid cementitious surface already fitted to them, they are perfect substrate to accept a layer of plaster. And that, ladies and gentlemen, is that. It was a whistle-top journey through our latest product. So sound absorption and fire protection. It does all that in one. So thank you very much for listening.